Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends, to your younger brothers and sisters who would want to take up engineering in the future, and to your relatives. That's one way you can keep me going, inspired, and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. Hello, students, subscribers, viewers, and future engineers. Here is another video on ratio and proportion problems here. These are light problems, but these are helpful in improving yourselves, particularly analyzing mathematical problems. So, problem 9. The sides of a polygon are 6, 10, 20, and 24 inches long. If the shortest side is reduced by 2 inches, what reductions should be made in the other sides to obtain a similar polygon? So take note that for similar polygons, the ratio of corresponding sides is the same. So that is for this shortest side here, it is reduced by 2, so 6 minus 2 over, so ratio of this next side, it is also reduced by R1, so reduction 1 of this side here. So 10 minus R1 should be equal to the ratio of the original side. So simplifying, 6 minus 2 is 4, then over 10 minus R1. Original sides were 6 and 10. So that's why we have 6 as to 10. So cross multiplying, 6 over 10, by the way, is 3/5. Cross multiplication, so 40 times 5, 20, equals 3 times 10, 30, minus 3 times R1. So solving for R1, we have 3R1 equals 20, equals 30 minus 20, so 10. Solving for R1, R1 is 10 thirds of 10 thirds inches. So that's the reduction to be made for this original 10-inch long side, so that the new polygon would be similar to the original one. So next, we have for 6 and 20. So 6 minus 2, so 4, as to 20 minus reduction for that side R2 equals ratio of original side 6 over 20. And 6 over 20 is 3 over 10. So 4 over 20 minus R2 is 3 tenths. Cross multiply, 40 equals 60 minus 3 R2. Solving for R2, 20, 60 minus 40, 20 divided by 3, so 20 over 3 inches. That's the reduction to be made for this side here. Then lastly, for the 24-inch long, so 4 minus 24, 4 over 24 minus R3 equals ratio of original dimension 6 over 24, or 1/4. So 4 over 24 minus R3 is 1/4. Cross multiply, 16 equals 24 minus R3. So R3 is 24 minus 16. So that means the reduction for this side should be 8 inches long. And you just check after reducing the sides 10, 20, 4. This is 10 minus 10 thirds, 20 minus 20 over 3, 24 minus 8. Those are the new sides. Then obtain the ratio. The ratio should still be the same correspondingly. A triangle whose base is 18 inches long has an area of 280 square inches. Find the area of a similar triangle whose base is 6 and 1/4 feet long. The area of triangle is 1/2 base times height. So for triangle 1 in particular, 1/2 B1 H1. For triangle 2, 1/2 B2 H2, where B1 and H1, or B and H, are the base and the altitude of the triangle respectively. So the ratio of triangle 1 to that of triangle 2 areas would be area triangle 1 over area triangle 2 would be, so 1/2 will be cancelled. So B1 H1 over B2 H2. And since the triangles are similar, that means the ratio of their corresponding dimensions should be the same or equal. So for triangle 1, ratio of base to that altitude B1 over H1 should also be equal to the ratio of base and altitude of the similar triangle, triangle 2. So that means B sub 2 is B1 H2 over H1. So the ratio of H1 over H2 rearranging is also ratio of B1 over B2. Now, B2 is 6 and 1/4 feet or 6.25 feet. Let's convert that to inches. So times 12 inches per foot. So that means base 2 is 75 inches. So replacing H1 over H2 ratio here by B1 over B2. So area triangle 1 over area triangle 2 is B1 over B2 times H1 over H2, which is B1 over B2. So for ratios of areas, it is simply the ratio of corresponding squares of dimensions. So you can also show that area of triangle 1 over area of triangle 2 is the ratio. So it is B1 square over B2 square here. You can also show that it is H1 square over H2 square. So y squared, ratio of corresponding squares of dimensions, because we are obtaining area of close polygons, in this case triangles. So area has units, square units, so the corresponding dimension should also be squared. So that's the reminder or common sense. So if it is ratio of volume for similar solids, then it should be the ratio of cubes of corresponding dimensions also. So that's the idea. So therefore, area of triangle 1 is 280, then area of triangle 2, the unknown area 2, equals base of triangle 1 is 18 inches, the other triangle 75 inches. So 18 square over 75 square. Solving for area 2, it is 4,861 and 1 over 9 square inches to be exact. Then problem 10. The area of a quadrilateral is 200 square feet and its shortest side is 10 feet long. Find the area of a similar quadrilateral whose shortest side is 15 feet long. So our solution should be based from our experience with this problem here. Uh, problem 10, this is problem 11. So area of quadrilateral 1 over area of quadrilateral 2 should be the ratio of corresponding squares of dimensions. So it is mentioned here shortest side, so shortest side 1 square over shortest side 2 square. So area of quadrilateral 1 is 200, quadrilateral 2 unknown. Shortest side of quadrilateral 1 is 10 feet, so 10 square. Shortest side, corresponding shortest side of quadrilateral 2 is 15 feet, so 15 square. Solving for area of quadrilateral 2, it is 450 square feet. Problem 12. The area of a quadrilateral is 200 square feet and its longest side is 20 feet long. Find the length of the longest side of a similar polygon whose area is 400 square feet. So again, our solution should be based from the preceding experiences that we have in problems 10 and 11. So area of polygon 1 over area of polygon 2 should be equated to the squares of the longest side of 1 and longest side of 2, square of longest side of 2. So area of polygon 1 is 200, polygon 2 400 square feet. Then longest side of polygon 1 is 20, longest side of polygon 2 is unknown, so L2 square. Solving for L2, because this is calculator aided, is 20 square root of 2 feet or in decimal 28.28 feet. So that's it for problem 12. Then lastly, problem 13. A basketball player is 6 feet inches tall. How far should he stand from a light which is 15 feet above the ground in order to cast a shadow 25 feet long? So this is the figure. So we have the basketball player, 6 feet 8 inches long. So let's convert it to feet. 8 over 12. So 6 and 2/3 or 20 over 3 feet. And this is the distance x where the basketball player should stand. So that in order to cast a shadow of 25 feet. So by similar triangles, we have x plus 25 as to 15 equals 25 as to 20 over 3, which is now this. And this is 25 times 3 over 20, the reciprocal, or 25 times the reciprocal of 20 over 3. And that is 75 over 20. So x plus 25 over 15 equals 75 over 20. X plus 25 equals 15 over 20 is 3/4 of 75. Solving for x is 31.25 feet. So that's it for this problem. I hope that you're able to understand the explanations and the solutions.